Hello everyone and welcome back to Math 143, Finite Mathematics. In our previous lecture, we learned how to solve systems of linear equations that have a unique solution using elimination and Gauss-Jordan elimination method. Today, we are going to look at systems that are little more interesting. Some systems have infinitely many solutions, some have no solution, and others still have one unique solution. By the end of this lecture, you will be able to recognize each type of system and determine its solution using Gauss-Jordan elimination. Okay, today's objectives are understand what underdetermined and overdetermined systems are. Also, review Gauss-Jordan elimination method. Identify whether a system has a unique solution, infinitely many solution, or no solution using Gauss-Jordan elimination method, and interpret the final row reduced matrix. Okay, let's begin with two important definitions. An underdetermined system. So, an underdetermined system has fewer equations than variables. An underdetermined system has fewer equations than variable. For example, if we have two equations but three unknowns, there usually is not enough information to determine a single solution. Usually it has infinitely many solutions. Instead, we often obtain infinitely many solutions because at least one variable is free. Okay, the next one is an overdetermined system. So, an overdetermined system has more equations than variable. Overdetermined system has more equations than variable. For an example, 4 equations and 3 unknowns. Sometimes all the equations are consistent and we obtain one solution. Sometimes one equation contradicts the others, resulting in no solution. So therefore, it may still have one solution or no solution. Okay, then before solving examples, let's review the 3 elementary row operations, the quick review of Gauss-Jordan elimination method. So the first one is interchange 2 rows. Second one, multiply a row by a non-zero constant. And replace one row by itself plus a multiple of another row. Okay, these operations never change the solution of the system. So our goal is always the same, reduce the augmented matrix to reduce row echelon form that calls RREF, where the solution can be read directly. Okay, let's begin with the example. So the given example, we have 3 equations and 3 variables. The first step is always to write the augmented matrix. So let's write the augmented matrix. 2, 1, negative 3, negative 1, 4, negative 2, negative 1, 1, 6, negative 3, negative 5, and 3. Okay, so work through the row operation slowly. take your time. And afterward, you will get the RREF 100, negative 1/2, 010, negative 9/7, 001, negative 3/7. Check your solution with this. So, we can write x equals negative 1/2, y equals negative 9/7, z equals negative 3/7. The final answer should be negative 1/2, negative 9/7, negative 3/7, a unique solution. As of the same way, the second exercise. So first write down the augmented matrix and find out the RREF, the reduced row echelon form, by performing the row operations. Okay, pause the video and take your time to solve the augmented matrix until you get the RREF form. Okay, so check your solutions, check your RREF matrix, the reduced row echelon form of the matrix with the answer. So this gives us x minus z equals 0 and y minus z equals negative 1. So that means we have only two equations at the end of the RREF form. Two equations but three variables. Also notice that the c, the variable c, is common in both. Therefore, let z is common, z equals t. Okay, let c equals t. Then x equals t from the equation 1, y equals t minus 1. Y equals t minus 1. So, we can write down the solution set x equals t, y equals t minus 1, z equals t. Okay, x, y, z equals t, t minus 1, t. Okay, then let me check. So, suppose t equals 0. What happened? So, when t equals 0, we will get the x, y, z solution set 0, 0 minus 1 minus 1, 0. When t equals 1, x, y, z, 1, 0, 1. When t equals 5, x, y, z, 5, 4, 5. What happened? So when t changes, the solution set changes. That means the infinitely many solution infinitely many solutions. Okay, let's go through the next example quickly. Write down the augmented matrix. 1, 1, 1, 2, 2, negative 1, 1, 3, 1, 2, 3, 1. Okay, pause the video again, do the operations until you get the RREF. So, therefore, x equals 11 over 5, y equals 3 over 5, z equals negative 4 over 5. So, the solution set x, y, z equals 11 over 5, 3 over 5, negative 4 over 5. A unique solution. Okay. Let's go for the one more exercise. Here, write down the augmented matrix 1, 1, 1, 2, 2, 2, 2, 5. What happened? After performing the row operations, what happened? Row operations. RREF could be 0, 0, 0, negative 1, 1, 1, 1, 2. So, what happened? There is a contradiction. 0 equals negative 1 from the last row. Contradiction. No solution. The system has no solution. Okay. So, notice that if we multiply the first equation by 2, we obtain the 2x plus 2y plus 2z equals 4. And the second equation is 2x plus 2y plus 2z equals 5. Then we can see that the contradiction. Therefore, the system has no solution. So, let's see the quick diagnostic. So, you don't always have to solve the entire system to understand what type of solutions you have. Right? So, let's add one page here. You don't always have to solve the entire system to understand what type of solution you have. Right? Remember these 3 rules. First one, if every variable column has a pivot. If every variable column has a pivot, that means every variable column has a leading coefficient 1. The system has one unique solution. Right? Also, if there is at least one free variable but no contradiction, if there is at least one free variable but no contradiction, that means the system has infinitely many solutions. Right? Also, finally, if you obtain contradiction row, then the system has no solution. Right? These three rules will help you quickly classify almost every system. Okay, now I would like to assign some exercises. So pause the video and try the exercises on your own. There are a lot of exercises. System of linear equations using Gauss-Jordan elimination method. First, for each system, write the augmented matrix. Okay, let me add the steps. Oops. For exercises, for each system, first write the augmented matrix. Second, perform Gauss-Jordan elimination method. Third, find the RREF. Fourth, decide whether the system has one unique solution, infinitely many solution, or no solution. After you have finished, compare your answers with the posted solutions. So let's summarize today's lesson. Today we learn the difference between underdetermined and overdetermined systems. We used Gauss-Jordan elimination to analyze different systems and learned how to recognize three possible outcomes: one unique solution, infinitely many solutions, or no solutions. The key idea is that the final row reduced matrix tells us everything we need to know about the system. Okay, so first go through the exercises and compare your answers with the posted solutions. Thanks for watching, and I will see you in the next lecture.